Ever wondered how your smartphone knows where you are? How you can instantly stream a video from halfway across the world? Or why your Wi-Fi just works? The seeds of our modern digital life were sown in a time of intense global rivalry, the Cold War, the paranoia, the technological race, and the sheer existential pressure between superpowers forced the creation of technologies that were decades ahead of their time. Today, we're counting down the top 10 Cold War inventions that secretly power your world. Let's start with number 10, spread spectrum communication. Back then, the problem was simple but deadly. How do you send a message if the enemy is trying to jam your radio signals? The answer was ingenious. Instead of broadcasting on a single easy two-target frequency, engineers developed systems that would rapidly hop between different frequencies or spread the signal out across a wide band, making it look like random noise to anyone trying to listen in or jam it. This is called frequency hopping in CDMA today. That same principle is why your Bluetooth headphones can connect in a crowded room, and why your Wi-Fi network doesn't collapse when your neighbors are all online. It's the invisible traffic controller for our wireless world. Coming in at number 9 is night vision. The goal was to own the night, to turn darkness into a tactical advantage. Early image intensifiers took what little light was available from stars or the moon and amplified it thousands of times, creating that iconic green glowing view. This push for low-light superiority eventually led to the development of solid-state imaging sensors, like CCD and CMOS chips. And what are those? They're the digital eyes in literally every modern camera. From your smartphone that takes stunning night mode photos to professional astrophotography telescopes and the CCTV camera on the street corner. Every time you snap a pic in a dim restaurant, you're using a direct descendant of Cold War battlefield tech. At number 8, we have radar and microwave technology. During the Cold War, seeing the enemy first was everything. Radar systems were developed to track aircraft, ships, and incoming missiles from hundreds of miles away, even through clouds and storms. Innovations like pulse Doppler radar could not only see an object, but also tell how fast it was moving. Phased array antennas could steer radar beams electronically without any moving parts. This tech is everywhere now. The weather report on the news, that's Doppler radar tracking storms. The adaptive cruise control in your car that automatically keeps a safe distance, that's a mini radar system. Even the automatic doors at the grocery store use microwave motion sensors. Number 7 is a little more abstract, but just as critical, the Kalman filter. Imagine you're in a submarine or a missile, and the enemy has jammed your GPS. How do you know where you are? You rely on internal sensors, gyroscopes that measure rotation, and accelerometers that measure changes in motion. The problem is, these sensors drift and accumulate errors over time. The Kalman filter is a brilliant mathematical algorithm that constantly takes in noisy sensor data, predicts where you should be, and then corrects that prediction with each new measurement. It's a self-correcting brain for navigation. Today, this exact logic is running inside your phone, combining data from its internal sensors to keep your map pointed in the right direction when GPS is spotty. It's also fundamental to camera stabilization, drone flight, and self-driving cars. Sliding into the number 6 spot is microelectronics. In the 1950s, computers were the size of entire rooms. That wasn't going to work in a missile guidance system, a fighter jet, or a portable command center. The military poured enormous resources into making electronics smaller, more reliable, and less power hungry. This was the birth of the integrated circuit, the microchip. They needed chips that could withstand the G-forces of a launch in the harsh environment of a battlefield. This relentless push for miniaturization and ruggedness is the direct ancestor of the processor in your smartphone, the chips in your laptop, and the tiny sensors that make up the Internet of Things. Every powerful device that fits in your pocket owes its existence to this Cold War imperative. At number 5, we have stealth technology. The logic was brutal. If radar can see you, it can shoot you down. So how do you become invisible? Two revolutionary ideas emerged. First, shaping. By designing aircraft with flat, angled facets, you could deflect radar waves away from the receiver instead of bouncing them back. Second, radar absorbent materials, or RAM. This is a special paint or coating that literally absorbs radar energy and converts it into heat. The result was aircraft like the F-117 Nighthawk, which looked like something out of science fiction. The principles of shaping signals and absorbing energy are now used in everything from drone design to the special shielding that prevents your electronic devices from interfering with each other. Breaking into the top four are intercontinental ballistic missiles, or ICBM. This might sound purely destructive, but the race to build reliable, continent-spanning missiles solved some of the hardest problems in engineering. You had to master multi-stage rocketry, create incredibly precise guidance systems to hit a target thousands of miles away, and design a re-entry vehicle that could survive burning through the atmosphere. This intense focus on high-reliability rocketry created the foundation for the entire modern space industry. Every satellite we launched heretofore, weather forecasting, global communications, or even those internet constellations like Starlink rides into orbit on rockets whose fundamental design and reliability were forged in the crucible of the ICBM programs. They turned weapons of war into our highways to space. Our top three begins with reconnaissance satellites. What is the other side building? This was one of the most important questions of the Cold War. The answer was to put eyes in the sky. Early spy satellites literally took pictures on film and then dropped the canisters back to Earth in a capsule to be caught midair by a plane. It was insane. This evolved into digital imaging, transmitting pictures from orbit in real time using multispectral and infrared sensors that could see things the human eye could use. This is the direct origin of Google Maps and Google Earth. Every time you zoom in on your house from space, you're using a civilian version of spy satellite technology. It's also used to track wildfires, monitor deforestation, and check the health of crops from orbit. The runner-up at number 2 is GPS, the Global Positioning System. We think of it for maps, but its original military purpose was about something else: timing. To launch a missile from a submarine or drop a smart bomb accurately, you needed perfect, synchronized time across the globe. The solution was a constellation of satellites, each carrying an incredibly precise atomic clock. By receiving signals from multiple satellites, a receiver on the ground could calculate its position anywhere on Earth through a process called trilateral. That system, created for war, now underpins our entire global economy. It guides Aruba, allows farmers to precisely manage their fields, synchronizes global financial trades, and so much more. GPS isn't just about location. It's the invisible clock that keeps the modern world running on time. And finally, the number one Cold War invention that completely redefined the modern world: ARPANET. In the darkest days of the Cold War, military planners asked the terrifying question: how do we maintain command and control if a nuclear attack wipes out our major communication hubs? The solution was a network with no center, no single point of failure. A decentralized web where information could be broken into small packets, each one finding its own path through the network and reassembling at the destination. If one node was destroyed, the packets would simply route around it. This radical idea of a distributed packet switching network was ARPANET, and it is the foundational blueprint, the very DNA of the internet you are using to watch this video right now. Every email, every search, every single click is a direct descendant of a system designed to survive the unthinkable. From stealth tech to the internet, the ghosts of the Cold War are all around us, hidden in plain sight inside the technology we use every day. It's a powerful reminder of how periods of intense conflict can unexpectedly give birth to innovations that ultimately connect us all. Thanks for watching. If you found this fascinating, hit that subscribe button and let us know in the comments which invention surprised you the most. See you in the next one.